Namaste children, welcome to today's mathematics class. Today we are going to discuss a new chapter, that is chapter number 7, coordinate geometry. And you are already familiar with this coordinate geometry in the previous class, that is in class 9 we have studied the coordinate geometry. So you are already familiar with this coordinate geometry. What we studied in class 9 we will review, we will recall what we studied, and especially mainly what we are going to study in class 10. It is the three topics are the main topics. Three topics are there. The three topics are distance formula, that is distance between any 2 points, the distance between any 2 points, how to find the distance between any 2 points. One formula is derived, that formula is known as distance formula. We will derive the formula and we will solve the questions related to distance formula. Then section formula, the second topic it is section formula. Find the coordinates of a point which divides, find the coordinates of a point which divides in the given ratio. Find the coordinates of a point which divides a line segment in the given ratio. How to find those coordinates when that line or that line segment is divided by another point? How do we find its coordinates? That is called section formula. Section formula, and its applications we'll study. Now area of triangle. The third one it is area of triangle. We are familiar with this area of triangle. We in class 9 we studied that is Heron's formula. We studied when we know the three sides of a triangle, and in the lower classes we are studying and we studied how to find area of a triangle when we know the base and height of a triangle. So half into base into height we studied, and Heron's formula we studied. Now in class 10 in coordinate geometry we are going to discuss derive one more formula for area of a triangle. When we know the three vertices of a triangle, how to find, that is area of triangle. This concept will study. So we are going to study in this chapter distance formula, section formula, area of triangle. Now I will start first with a review what we studied in class 9. What we studied in class 9 we will revise. So in class 9 you studied how to locate a point or how to give a position to a point in class 9. So to give a position to point we have taken two values, that is x value and y value. X value and y value. For example, you take what we call this line, it is vertical line and we call this as y-axis, and this is a horizontal line and we call this as x-axis. That is a plane is divided into four parts. So each part is known as a quadrant. So this is the first quadrant, second quadrant, third quadrant and fourth quadrant. We studied in class 9. So for example, if you want to locate a point, here is a point A. So this point is 3, 4. Its coordinates are 3, 4. What is 3 and what is 4? So for example, if you take a point, here is a point, this point coordinates are x, y. Then what is x and what is y? We will discuss that. We studied in class 9. You see here, the two coordinate axes, x-axis and y-axis, are intersecting at a point. This point is called origin and it is represented with a letter called O, capital O. So what is origin? The point of intersection of coordinate axis, that is x-axis and y-axis. Now, so what are the coordinates of this point O? It is 0, 0, 0, 0, and right side will take the values 1, 2, 3, 4, 5, and left side will take -1, -2, -3 on x-axis. Above this 0 or above the origin on y-axis will take positive values 1, 2, 3, 4, and here it is -1, -2, -3 and -4. Like this will represent the values on the coordinate axis. So if you want to locate a point, we will locate a point 3, 4. Where we can locate this point 3, 4? It is we call this as the first quadrant. 3, 4 means x is 3 and y is 4. So that is 3, 4. What it says 3 and what it says 4. So here the 3 is representing, what is this? This is the distance from the y-axis. This is perpendicular distance, perpendicular distance, perpendicular distance. So that perpendicular distance from y-axis, the perpendicular distance from y-axis is called x coordinate. So here 3 is known as what? X coordinate. 3 is known as x coordinate. 3 is known as x coordinate, and it is also known as other name, it is there, abscissa. Abscissa. We studied in class 10th, 9th. Then what is this? This 4 is representing how many units this point is there from x-axis. You take this is the distance. How many units are there? It is 4 units. So this 4 is representing what? The perpendicular distance from the x-axis. The perpendicular distance from the x-axis is known as y coordinate. Y coordinate, and it is also known as other name is there. It is simply it is known as ordinate. Ordinate and abscissa. Remember here in this point 3, 4, abscissa is 3 and ordinate is 4. Ordinate is 4. So simple here you write points. The perpendicular distance. The perpendicular distance from y-axis. From y-axis is called. It is what we call the perpendicular distance from y-axis. This is called perpendicular distance from y-axis. What we call it is x coordinate. Is called x coordinate, and it is also known as, abscissa. Abscissa. So abscissa is also known as x coordinate and is the perpendicular distance from the x-axis. Then what we call the perpendicular distance. The perpendicular distance from x-axis, is called y coordinate. Is called y coordinate, or simply it is called ordinate. Now if we take a point in 3, 4, in 3, 4, 3 is called what? Abscissa. In 3, 4, 3 is called abscissa. 3 is called abscissa or x coordinate. Abscissa or x coordinate, and 4 is called what? Y coordinate, or it is ordinate. Simply 4 is called ordinate. So like this we will represent a point with the two values, that is x coordinate and y coordinate. X coordinate is known as abscissa and y coordinate is known as what it is? Ordinate. So similarly it is now we call what is x coordinate and what is y coordinate. What is origin here? It is origin is the point of intersection of x-axis and y-axis. X-axis and y-axis is called origin. And it is represented with what? And it is represented with O, the letter called O, capital O, and the coordinates are what? 0, 0. So the coordinates of origin are 0, 0. What is origin? The point of intersection of x-axis and y-axis, and it is divided into 4 quadrants. First quadrant, second quadrant, third quadrant and fourth quadrant. We have studied in first quadrant both x value and y value both are positive. X is positive, y is positive. Whereas in second quadrant the x is negative and y is positive. And the third quadrant both are negative. X is negative, y is negative. And in fourth quadrant x is positive and y is negative. So we studied all these things in the class 9. So now with this, so this is a brief introduction, a brief revision from class 9. What is point? What is origin? How do we represent a point with what values? What we call the name of that coordinate, that is x coordinate and y coordinate. X coordinate is known as abscissa and y coordinate is known as what it is? Ordinate. Y coordinate is known as ordinate. So x coordinate is nothing but the perpendicular distance from y axis, and y coordinate is nothing but the perpendicular distance from x axis to that point. Now we are going to discuss about what it is distance formula in detail in the class 10. Is it clear, children? So far what we discussed here it is? Yes. Now we will discuss points on x-axis, points on y-axis, points in the first quadrant, second quadrant, third quadrant and fourth quadrant. So first quadrant, what are the points in the first quadrant? First quadrant, quadrant 1. So what are the points? Generally in first quadrant both are positive, x is positive and y is negative, like 2, 3 or 3, 2 or 4, 1, 5, 1, like this. Quadrant 2, what are the points in quadrant 2? Quadrant 2. So in quadrant 2, x is, this is left side is there, x is negative and y is positive, minus comma, it is plus. Therefore what are those? It is minus 2, 3, minus 3, 5, minus 4, 2, minus 5, 1 are some of the examples which these points lie in the second quadrant. Quadrant 3, in quadrant 3 both are negative, that is x coordinate is negative and y coordinate is also negative. Therefore it is minus 2, minus 3, minus 3, minus 4, minus 3, minus 5, etc. See in quadrant 3, x is negative, y is negative, that is x values are negative and y values are negative. Examples: minus 2, minus 3, minus 3, minus 4, minus 3, minus 4, that is both x coordinate and y coordinate both are negative. In quadrant 4, x is, this is quadrant 4. In quadrant 4, we have x is positive and y is negative. X is positive and y is negative. Therefore, the points are 3, minus 2, 2, minus 3, 4, minus 5. Like this these are the points in the fourth quadrant. Now, what are the points on x-axis? Point on x-axis. You see here, point on x-axis. So here, this is a point on x-axis. How do you represent it? Is 2, 0. X is 2 and y is 0. And this point is representing 3, 0. X is 3, 0, y is 0. Therefore, it is 3, 0. And here it is minus 2, 0. This is minus 3, 0. So, points on x-axis, it is 2, 0, 3, 0 and minus 3, 0, minus 4, 0. So, in general, what we can say, that is, x, 0 is the point on x-axis. Means y is always 0. A point on x-axis, its y coordinate is 0. A point on x-axis, its y coordinate is 0. Therefore, it is x, 0. Similarly, points on y-axis. Points on y-axis. What are the points on y-axis? You see here this point. So here this is representing x is equals to 0. So 0, 3 and this is representing 0, 2 and this point is representing 0, minus 2. This point is representing 0, minus 3. Therefore, the points on y-axis are 0, 1, 0, 2 and then 0, minus 2, 0, minus 3, etc. All these are the points on y-axis. A point on y-axis, its x coordinate is 0. A point on y-axis, its x coordinate is 0. Therefore, in general, the point on y-axis is 0, y. A point on y-axis is 0, y. So, a point on x-axis is x, 0. Point on y-axis is 0, y. Where a point on y-axis, x coordinate is 0. A point on x-axis, its y coordinate is 0. So these are the few examples of points lying on the first quadrant, second quadrant, third quadrant, or in fourth quadrant, or on x-axis, or on y-axis. As I told, origin coordinates are what? What are the origin coordinates? Origin coordinates 0, 0. Origin coordinates are 0, 0. Now we will discuss what is the distance between 2 points. Distance between 2 points in detail we will discuss in the form of distance formula. Is it clear, children? Yes. Now we will discuss the first concept of class 10, coordinate geometry. Distance formula or distance between 2 points. Distance between 2 points. For example, let P is a point with x1 comma y1, and this is Q is a point with x2 comma y2 are the coordinates. Then by joining these 2 points we will get a line segment. That line segment is known as length of PQ or distance between PQ. So distance between PQ is distance between the 2 points P and Q. Distance between P and Q is equals to length of PQ. Length of PQ line segment. Length of PQ line segment. Now how do we find the length of this line segment when we know the coordinates, that is x1 y1 and x2 y2. When we know these 2 points, their coordinates, how to find? Here different cases are there. In that the first case we will study if the 2 points are there on x-axis. If the 2 points are there on the x-axis, how to find the distance between? Case 1, 2 points on x-axis. 2 points on x-axis. Then how do we find the distance? See, let here you take this is a coordinate axis. Let this is x-axis and this is y-axis. X-axis and y-axis. This is origin 0, 1, 2, 3, 4, and still if you want you extend it 5 and 6. This is x-axis. Let this is point A. So how do we represent this point A? These coordinates are 3, 0, and let this is 1, 2, 3, -1, and it is -1. You see, let point, this point is A, and this point is what it is B, and this point coordinates are 6, 0. How do we find the length, the distance between points A and B? Point A and B. Now, how much these 2 points are there on x-axis? What is the how much distance or how much distant away from the y-axis? This 3 is representing what it is, the perpendicular distance from y-axis. Now this is the distance. Let this point is O and this is the origin. So this length will give you what it is OA, and this length will give you what it is OB. So here OA is equals to how much it is? OA, this is 1, 2, 3, 3 units is there. OA is 3 units. Then how much is OB? OB is how much it is? 6 units are there. OB is 6 units. This is OB. Now AB we need to find. AB is equals to what? OB, length of OB minus length of OA. Length of OA is what? 3 units. Length of OB is what it is? 6 units. Then their difference 6 minus 3 is equals to what it is? 3. So here AB, length of AB is equals to length of OB minus length of OA. Length of OB means it is 6 units minus OA it is 3 units, that is 3 units. Length of AB is equals to 3 units. How we got 3 units? By subtracting their x coordinates. By subtracting their x coordinates. So here if we take any other points also on the x-axis, even in the what it is negative axis also, we will subtract their x coordinates, and the result which we get, that is the distance between the 2 points on x-axis. If 2 points on x-axis, then what is the distance? Let it is A x1 comma y1 and B x2 comma y2, or let A x1 comma 0 and B x2 comma 0 are 2 points on x-axis. Then the length of AB is equals to what? The difference of their coordinates, that is x2 minus x1 units. x2 minus x1 units. This is the distance between the 2 points on the x-axis. That is the first case. Second case, if the 2 points are there on the what? Y-axis. 2 points on y-axis. 2 points are on y-axis. Then how do we find the distance between those two points? So let this is y-axis, and here it is x-axis. So we are representing y axis and this is x axis 0 and it is 1, 2, 3 and it is 4. 1, 2, 3, minus 1, minus 2, minus 1 and it is minus 2. Now you take this is a point A. So here A can be represented as what? X is 0 and y is 1, that is 0 comma 1, and you take this is the point B. How can we represent it is 0 comma 4. Now how do we find the distance between what it is AB? The distance between AB is equals to OB minus OA. So this will give us what? OA. How much it is? 1 unit. And this will give us what? OB. How much will it give us? OB, how many units it is? 4 units. Now by their difference what we get? 3 units. That is let A 0 comma y1 and B 0 comma y2 are 2 points on y-axis. Then the length of AB is given as the difference of those two lengths. This is OA 1 unit, OB is 4 units. Now you even count here it is. This is 1 unit, 2 units and 3 units. 4 minus 1 is also equals to it is 3 units. 4 is the y2 and 1 is the y1. Therefore AB is equals to y2 minus y1. y2 minus y1. So by subtracting the y coordinates we will get the distance between 2 points on y-axis. By subtracting the x coordinates we will get the distance between 2 points on the x-axis. Now we will discuss if the 2 points are there on either axis, that is one point is on x-axis, the other point is there on y-axis. How to find the distance between the 2 points? That is third case. Now we will discuss case 3. One point on x-axis and the other point is there on y-axis. Let a point on x-axis, this point is P, and what is the coordinates of this point? It is coordinates of this point, it is x is equals to 4 and y is equals to 0. Next point, this is point Q, and how do you represent? X is 0, y is 3, 0 comma 3 and 4 comma 0. Now how do you find the distance between these 2 points? What are the 2 points P and Q? And what is the distance between these 2 points? P, by joining these 2 points we will get PQ. Now what type of triangle we got here? It is a right angle triangle we got. So to find this distance, this is the hypotenuse of this triangle, that is, and it is opposite to the right triangle. By applying the Pythagoras theorem we can find the distance between 2 points if the 2 points are there on the x-axis and on y-axis. That is, one point is on x-axis, the other point is there on y-axis. Now what is this distance? Let this is O, point O. So what is this distance? It is from O to P is, that is the perpendicular distance. How many units are there? 4 units. So OP is equals to 4. And similarly OQ is equals to how much is this? It is 3 units. OQ is how much it is? 3 units. We want to find PQ. Now consider in triangle it is POQ. In triangle POQ, angle O is equals to 90 degrees. So by Pythagoras theorem, square of the, what is Pythagoras theorem? In a right angle, the square of the hypotenuse, that is PQ square, is equals to sum of the squares of other 2 sides. What are the 2 sides? OP and OQ. Their squares, OP square plus OQ square, which is equals to how it is? By Pythagoras theorem. By Pythagoras theorem. By Pythagoras theorem, it states that square of the hypotenuse is equals to sum of squares of other 2 sides. That is equals to OP is equals to what it is? 4 units. Therefore, it is 4 square. And OQ is equals to what it is? 3 units. Therefore, it is 3 square. 4 square it is 16 plus 3 square is equals to 9, that is 25. PQ square is equals to 25. PQ is equals to square root of 25, that is equals to PQ is equals to what? 5. Here we will get 2 values, plus 5 and minus 5. Distance will always positive, it is never negative. So we will consider always the positive value only. That is square root of 25 will get 2 values. plus 5 and minus 5. Minus 5 will be ignored. Why? Distance, we are discussing the distance. Distance, it is the measurement. It is never negative. Therefore, we will consider positive value. So, now how do we find the distance between 2 points on one point is there on x-axis, the other point is there on y-axis? By using what? Pythagoras theorem. That is 4 square plus 3 square. Now we take, we can generalize this. Let p x comma 0 and q 0 comma y are 2 points on x-axis and y-axis, and y-axis respectively, or on x-axis and y-axis respectively. Then the distance between PQ, then the distance between P and Q, that is point P and Q, is represented by what it is? PQ, that is equals to square root of, what is the distance from origin to point P? It is x units and this is y units, that is equals to x square plus y square. What is here? It is 4. 4 is nothing but x coordinate of point P and 3 is nothing but y coordinate of point Q. If it is 0 comma y and this is x comma 0, we got x square plus y square. So we will find this distance by using this formula. PQ is equals to square root of x square plus y square. If the 2 points are there on x-axis 1 point and y-axis is there on that point. Now we will discuss case 4. If what is the distance from a point from origin? Origin is also a point. That is the distance between origin and a point on any quadrant. Origin and a point on any quadrant. That is 4th case we will discuss now. Is it clear, children? Now case 4. Distance between a point in any quadrant and origin. Let you take a point, that is you take this point as O, or sorry, P. P is this point. What are the coordinates of this point? X is 4 and y is 3. Therefore, it is 4 comma 3. And this is the origin. What is the distance? That is OP. We have to find this distance. How much is this distance? We need to find. OP is how much? So how do we find? That is distance between origin and a point. What are the coordinates of origin? It is 0 comma 0. So for that, to find that, draw a perpendicular. Let this is the perpendicular drawn at here. Let this point is Q. This point is Q. Now what is this length? What are the coordinates of point Q? Here x is 4 and y is 0. 4 comma 0. Again we got a right angle triangle PQO or POQ, where angle Q is 90 degrees. Therefore OP is the hypotenuse. So again, by applying the Pythagoras theorem, we can find the distance between a point in any quadrant. Either you can take here or here or here or in the 4th quadrant from origin. So by drawing this, now what is this distance? OQ is equals to how many units it is? 1, 2, 3, 4. That is x coordinate will give us 4 units. And what is the length of this QP or PQ? It is 3 units is there. This is this distance and this distance, both are same. That is 3 units. 3 units till here it is. Now we need to find what is OP. So for that, use Pythagoras theorem. In triangle PQO, angle Q is equals to 90 degrees. Therefore, by using Pythagoras theorem, square of the hypotenuse, that is OP square, is equals to sum of the squares of other two sides, that is OQ and PQ. OQ square plus PQ square. So OQ is equals to 4 units and PQ is 3 units. Therefore, it is 4 square plus 3 square, which is equals to 4 square is 16 and 3 square is 9. 16 plus 9, it is 25. Again, OP is equals to square root of 25, that is OP is equals to 5 units. Again, here we will get 2 units, sorry, 2 values, positive value and negative value, but we will consider always a positive value. So how do we find distance between origin and a point in any quadrant? By using the Pythagoras theorem. So now how do we find in general, In general, how do you find? Let p x comma y, p x comma y is a point in any quadrant, and the distance between point P and origin. So what are the coordinates of origin? It is 0, 0 is. So how do we find? Here 4 is stands for what it is? X coordinate of point Q. That is x point P. It is left. If this is x comma y and this is origin. So 4 stands for x value and 3 stands for what it is? Y value. Therefore, it is given by the distance OP is equals to square root of x square plus y square. What are x and y? They are the coordinates of the point in any quadrant. Therefore, the formula is square root of x square plus y square. So far, we have covered 4 cases. First case, if the 2 points are there on x-axis, then we will subtract their x coordinates, we will get the distance. If the 2 points are there on y-axis, by subtracting their y coordinates, we will get the distance between the 2 points. Then the third case, if one point is there on x-axis, the other point is there on the y-axis, how do we find the distance? That is by using the Pythagoras Theorem, we will get square root of what it is x square plus y square. Similarly, if a point is there on any quadrant from origin, how do we find? That is square root of x square plus y square. So then, now in general, if the 2 points lies in any quadrant, how do we find the distance between those 2 points? That is the main formula, and we call that formula is known as distance formula. We will derive a formula for that, how to find the distance between 2 points in any quadrant. So far, do you understand, children? Yes? Now we will discuss a distance formula, that is distance between 2 points. Let consider 2 points P, x1 comma y1 and Q, x2 comma y2 are 2 points. Then the distance between them is given by the derivation we will discuss here. What is the distance between these 2 points? By joining these 2 points, we will get a line segment. That line segment will give us the length of the PQ will give us the distance between 2 points. How do we find? So here draw PQ is perpendicular to, this is x-axis and it is y-axis. PQ is perpendicular to x-axis, and from point Q draw one perpendicular, that let it is PR is perpendicular to x-axis from point P, and from point Q draw a perpendicular, that is QS is perpendicular to x-axis at point S, which is drawn from Q. Similarly, draw a perpendicular from point P, from this point to QS, draw a perpendicular. Now this is perpendicular and you take this as point T. So here 3 constructions. From point P, draw PR, and from point Q, draw QS are perpendicular to x-axis, and PT perpendicular to what it is? This QS drawn from point P. Now here we got a triangle. PTQ is a triangle. What type of triangle it is? Right angle triangle. We need to find this distance, that is hypotenuse. If you know this distance PT and if you know the distance TQ or QT, then we know these 2 distances when we can find by using the Pythagoras Theorem. Now here PT is equals to RS. These 2 are equal. It is what? A rectangle we got. And both RS is equals to what it is? PT, and similarly PR, these 2 lengths is equals to what it is? TS. PR is equals to TS, RS is equals to QT. Now what is this point? It is, what is this distance? It is x1. This is x1. So this point R can be written as what? x1 comma 0, and this is what? x2 comma 0. Now let O is the origin. Now what is this distance? OR will give us what? x1 units. And what is this distance will give us? OS will give us x2 units. x2 units. We require rs. Rs is equals to os minus var. Os minus var. Os is x2, var is x1. The difference will give us what? x2 minus x1. And we know rs is equals to pt. Therefore, this length is equals to what? x2 minus x1. x2 minus x1. Similarly, from this, we wanted to find qt. Qt, this length, qt is equals to qs minus ts. qs minus ts. ts will give you what it is? y1. So, this length is equals to what it is? y1. And qs will give us what it is? y2. This total length it is y2. This length is y2. That is, y2 stands for what is y coordinate? The perpendicular distance from x-axis, it is y2. And for this point, the perpendicular distance from what it is x-axis, it will be y1. This length and this length both are equal. So now what will give you this length? Qt is equals to, that is qs minus est, y2 minus y1. Now we know the two perpendicular sides of the right triangle. Then we need to find the hypotenuse. That hypotenuse will give us the distance between 2 points. So here what to do? Draw from point P and point Q two perpendiculars, that is PR and QS, to x-axis. Then draw PT perpendicular to QS from point P. Then find the length of PT and length of TQ in the triangle, right angle triangle TQP or PQT. Then apply the Pythagoras theorem. We will get the length of PQ. So here what is the construction? Draw PR perpendicular to PR and QS from point P and Q. Point P and Q. Draw PR and QS from point P and Q. Draw PR and QS perpendicular to x-axis. Then second construction it is draw PT perpendicular to QS. Draw perpendicular to PT perpendicular to QS. It is. Now from the figure, observe the figure right there in what we require. OR is equals to x1, and OS is equals to x2, RS is equals to OS minus OR. RS, this length is equals to this total length minus OR, that is equals to what? It is x2 minus x1. Similarly, from that it is ST is equals to y1 and what it is QS is equals to y2. Now QT is equals to QS minus ST, that is y2 minus y1. QT is equals to what? y2 minus y1. RS is equals to what it is? x2 minus x1. Now consider the triangle. In triangle PQT, angle T is equals to 90 degrees. Therefore, by applying Pythagoras theorem, square of the hypotenuse, that is PQ square, is equals to sum of the squares of other two sides. What are the other two sides? It is PT square plus QT square. PT square plus QT square. PT is equals to what we got? It is RS we got here. I'm sorry, here RS we got. RS is equals to what it is? PT. Here we can write RS, that is RS, that is also equals to PT. And here we got QT. PT is equals to what it is? RS, which is equals to x2 minus x1 whole square, plus QT is equals to y2 minus y1 whole square, that is PQ square. Now PQ is equals to transpose square to or HS, it will become square root of x2 minus x1 whole square plus y2 minus y1 whole square. So this formula is known as distance formula. This formula is known as distance formula. So like this we'll derive this formula. So this also can be written as PQ is equals to square root of x1 minus x2 whole square plus y2 minus y1 minus y2 whole square. y1 minus y2 whole square also we can take. Why we can take? Because x2 minus x1 we get value, and x1 minus x2 we get the same value with the different signs, that is plus and minus will be there. Then the square of a negative value or a positive value is always a positive value and we will get the same value. So we also can write this. Now this formula is known as distance formula. So what is distance formula? Length of PQ is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. What we applied here, it is Pythagoras theorem. Pythagoras theorem we applied. So did you understand, children? What we applied here, it is Pythagoras theorem, and we got PQ is equals to square root of x2 minus x1 whole square plus y2 minus y1 whole square. So this all whatever we studied, that is case 1, case 2, case 3, case 4 also we can derive those from this formula also, from this formula itself. That's why it is known as distance formula. Remember, the distance PQ is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. With this knowledge, we will solve some of the questions. Clear? I hope you understand today's concept, and we will continue its application, that is solving the problems by using distance formula in the next class. Thank you very much.